Okay, so let's take a look at some examples where we would use and apply the log laws. Okay, so first of all, we have log, our example A here, we have log 5 plus log 3. So if we write this as a single log, this would be log, and then the 5 and the 3, they would be multiplying with each other. 5 times 3 is 15, and that would be our final answer. Okay. Example B here, since this log here is negative, we know the 8 is going to be in the denominator. So we have log base 3, 24, right, divide by 8. We know 24 divided by 8 is 3, and then you should recognize this is one of our special cases. All right, if the base and this value is the same, we know this equals 1. Okay. This one's a little bit tricky because what happens is, first of all, the incorrect thing to do is you cannot take 5 minus 1 because you have to think of this as one whole term. Okay, so this 5 is part of this log, right? And this is just a normal 1. So you cannot take 5 minus 1 and say, oh, this is going to become 4. This would be incorrect. Okay, so what you want to do is, well, you need to change this 1 into a log. So we have log base 2 of 5 minus. Now, since this is log base 2, we need logs in the same base to use the properties or the laws. So log base 2 of what is going to give us 1? Well, this has to be a 2. So now that we have the same log with the same base, right, we can write it as a single log. So this would be 5 divided by, all right, 5 divided by 2. All right, let's take a look at another example. Okay, let's take a look at this example here. So we need to first write it as a single log. So first of all, this 2 that's in front of the log, that's multiplying with this log 7, we can remember, we can use the property, the law, and move that to make that the decimal. So when we condense this into a single log, this would become 7 squared divided by, and then we would get, this would also become the exponent over here. So we would get 2 to the third power. So that's going to give us log 49 divided by 8. Okay. Over here, once again, you need to change this 3 into a logarithm, right? So first of all, we have 2 log 3 plus, now this is a log with a base 10. Now remember, when there's no number here, there's an imaginary 10. So you have to think, well, if this is a 10 right here, what are we going to have here that's going to give us a value of 3? Well, 10 to the third power is 1,000. So this has to be 1,000. Okay? So then when we condense it, this 2 becomes the exponent. So we would get log 3 squared times 1,000. So that's going to give us log 9,000. Okay? Over here, now first of all, you cannot divide this, right? You cannot just divide this right here and say this is 2. Okay, that would be incorrect. Okay, you have to think of this as its own term. All right, now if this was log 8 divided by 4, then you can divide this. Then that's fine. Then you can divide 8 into 4. But when it's like this, written like this, all right, you cannot divide the 8 into 4. So what do we do? Well, we can take the 8 and change it to 2 to the third power. On the bottom, we have the 4 changed to 2 squared. And using the property, we can move the exponent to the front. So we'll get 3 log times log 2 over 2 times log 2. And now that you have 3 times log 2 and 2 times log 2, we'll be able to divide out these factors. So then we're going to end up with 3 over 2 as our final answer. Okay? All right, so let's take a look at this question here. So these are very common questions that IB likes to give. So we're given some information here, right? So they tell us P is equal to log base B of 3, Q equals log base B of 5, and R equals log base B of 7. So they want us to write the following expressions in terms of P, Q, and R. All right, so one thing you need to remember is anytime a question says in terms of something, that means that that something, all right, should be written, all right, in your answer. So in this case, in terms of PQR, that means our answers should have the letters P, Q, and R are in it, along with maybe some numbers. Okay? So let's take a look at example A here. So first of all, so here's the key. So you have to see which values they're giving you, right? So we're working with 3, 5, and 7. So you want to use these values, right, to try and get this number. So we know that, well, I know that, well, 3 times 5 gives me 15. And I notice I have a 3 and a 5 here, right? So that's perfect. Now if I expand this, so here's the key, you need to expand this, right? So we have log base b of 3 plus log base b of 5. And then we can substitute. We're told that log base b of 3 equals p. So this is p plus log base b of 5, right, equals q. So this is q. Okay? Over here we have log base b. How do I get 105? So you have to think. Remember, you're working with 3, 5, and 7. Well, I know 35 times 3, that's going to give me 105. Okay? Now 35, right, I don't see a 35 here, so you have to continue breaking this number down. So log base b, 35 is going to be 5 times 7, and then times 3 over here. So this would give me 105. Now I need to expand it out. So this is going to give me log base b of 5 plus log base b of 7 plus log base b of 3. And then we substitute log base b of 5 to tell us it's q. This is q plus log base b of 7, that's r, plus log base b of 3, right, that's p. Okay? Over here, we know this is log base b. This can be written as 7 squared. And when we expand, we can move the 2 to the front. So 2 times log base b of 7. And then when we substitute log base b of 7, that gives us r. So we have 2 times r. Okay? Okay, let's take a look at some more examples here. So we have log base b. So this 25, I'll write that as 5 to the second power divided by 7. So if we expand this, this 2 is going to move to the front of the log. 2 times log base b, right, of 2. 2 times log base b, of 5, right, minus the 7 is in the denominator, so the log must be negative, minus log base b, right, of 7. And then we can substitute log base b of 5, they tell us is q. So this would be 2 times q minus log base b of 7. We know that's r. Okay? Over here, so over here, let's see, we have log base b, 1 over 21. So the first thing is I can move this 21 to the top. So I'll make this 21, right, to the negative 1 power, right? And then we have log base b. So 21 here, I know 21 is 3 times 7, right? That gives me 21. Now I have this negative exponent out here. So what I need to do is I need to distribute the negative exponent to both of these, okay? So basically this would become log base b of 3 to the negative 1 power and 7 to the negative 1 power. So when I expand this, this would be log base b with a negative 1 in the front. So you just put the negative there, all right, of 3 minus, all right, so I move the negative to the front. All right, so we have minus, and then we have log base b of 7. Okay, and then we can substitute. So when we substitute, we're going to end up with right here negative log base b of 3, that's p, negative negative p minus, and then log base b of 7, that is r. All right, so negative p minus r. Okay, f here. So we want to change this radical into exponent form. All right, so log base b, this would be 3 to the 1/2 power. Move the 1/2 to the front, multiply with the log base b of 3, substitute, so we'll get 1/2 times log base b of 3, which is p. Okay,